In this section, we'll be talking about graphing nonlinear equations and solving these systems that they create. So we're not always going to have a line in this case. We're going to have some graphs like this one that is not a line, and instead it is a parabola. Okay, we're going to get into circles and ellipses and other types of graphs. This one is going to be a line. So in case we have a parabola and a line, we have three possibilities. In this case, we could have the parabola and the line intersect at 2 points, and this would be two solutions. We could have them intersect at only 1 point, so just coming and touching at 1 point, or we could have them not intersect at all. So if my graph, my parabola looks like that, and my line is all the way down here, for example, they're never going to intersect, so no points of intersection here. Okay, so the solution set is going to be the set of all ordered pairs that satisfy both equations in the system. Essentially, we are finding their intersection, so think about where these graphs intersect. Okay. So let's go ahead and jump right into this. We are going to solve by substitution in this first example. So I'm going to go ahead and rearrange the second equation. I'm going to move the 3x over. That gives me negative y equals negative 3x plus 9. But then I'm going to multiply everything by a negative 1 so that the negative goes away. Then I have y equals positive 3x minus 9. So that is the equation I'm going to use to substitute. I'm going to take that and I'm going to substitute it in over here where it says y. So that gives me x squared equals 2 times, instead of y, I'm putting in 3x minus 9 and then plus 10. So I distribute the 2. I get 6x minus 18, and then I still have the plus 10 there, and the x squared in the front. Okay, now this is starting to look like a quadratic, so I'm going to go ahead and simplify this a little bit more. Negative 18 plus 10 is negative 8. I have the 6x and the x squared here. So I'm going to move everything to one side, and I like to keep my x squared positive, so I'm going to move the 6x. And I'm going to move the 8 as well. That gives me x squared minus 6x plus 8 equals 0. So now that this is a quadratic, I can go ahead and factor from here. So thinking about what two numbers multiply to 8x squared, but also add up to negative 6x. So we know it's going to be 2 and 4 somehow. But then one of them needs to be negative for theirs to be, or some of them needs to be negative for them to be a negative sum. So in this case, it is actually both of those. Okay, so I'm going to use factor by grouping here. I'm going to split up this middle term. It's going to give me x squared minus 4x minus 2x, and then plus the 8. And group the first two terms, the last two terms, which I can take out an x for the first term and leaves me with x minus 4. I can take out a negative 2 in the second term and leaves me with x minus 4. The factor that I have in common is one factor, and whatever I took out is another factor. Okay, I'm going to set those factors equal to 0. So I'm going to take the x minus 2, set it equal to 0, and I'm going to take the x minus 4, set it equal to 0. So I have x equals positive 2 and x equals positive 4. Now, I need to find where they intersect, okay? So I need to figure out my y value. These are my x values. I'm going to have 2 points of intersection. One of them is going to be at 4 something, and the other one is going to be at 2 something. Those are the x values I just found. Now I need to figure out what y value they intersect at. So what I'm going to do is I'm going to substitute these values back into my original problem. Let's see here. So When x equals 4, and I substitute it back over here because this is already set to y equals, I have y equals 3 times 4 minus 9. Well, 3 times 4 is 12, minus 9 is 3. So the 3 goes with the corresponding 4x value, so I'm going to put the 3 right there. I'm going to do the same thing now when x equals 2 this time. Y equals 3 times 2 minus 9, which is 6 minus 9, so y is negative 3. So the y negative 3 corresponds to the x 2, so I'm going to put the negative 3 right there. So I have 2 points of intersection, and let's take a look at what this graph is actually going to look at to confirm that they intersect at 2 points. In this case, when I graph both of those, I'm using Desmos. You can use your graphing calculator. We have an intersection right there at 2, negative 3, and the intersection there at 4, 3. So this, there's 2 solutions because the graphs intersect each other twice. Okay? Let's keep going. Going on to the next example. In this example, we have x minus y equals 3, which is the equation of a line. I'm going to rearrange this to be y equals x minus 3. So again, this is going to be a line. And the second one is actually going to be the graph of a circle. So again, I'm going to show you this on Desmos here in a moment, but just keeping in mind how many potential answers there could be with a circle and a line. So I'm going to be using substitution here. That's why I rearranged the first equation. I set this y equal to x minus 3, so I'm going to come here and substitute that into my equation. So my original equation is x minus 2 squared plus y. So instead of y, I'm going to say x minus 3, and then keep going, plus 3 squared equals 4. So what's going to happen here, these are going to cancel out because that's negative 3 plus 3. And that leaves me with x squared for that second term. Then I have x minus 2 here, that's being squared, and that equals 4. So I'm going to expand my x minus 2 squared, which means it's x minus 2 times x minus 2. And plus x squared equals 4. This we double distribute and get x squared minus 4x plus 4. And I still have that plus x squared equals 4 here. It's starting to look more simple, I guess you could say. So we're going to start combining like terms. I have x squared plus x squared, which gives me 2x squared. And then I have this negative 4x. And then if I move this negative 4 over this way, they're going to cancel out. So then I just have that equal to 0. Okay? Then I can factor out an x. So x comes out. Actually, 2x can come out. Then I have x minus 2. And when I set each of those factors equal to 0, 2x equals 0, and x minus 2 equals 0, I get x equals 0, x equals 2. Okay? So then keep going. You also have to figure out where these are intersecting. So again, these x values are just the first number in your coordinate point. Oops. And this one's going to be 2 something. So we got to figure out what that x value is going to be. So when x equals 0, what is y going to equal? I'm going to just use this one again that I already rearranged. So y equals 0 minus 3. Therefore, y is negative 3. So y is going to be negative 3 when x equals 0. And when x equals 2, I substitute that in, 2 minus 3, I get negative 1. So y is going to be negative 1 when x is 2. So let's go ahead and check our graph. Okay, here's my graph. I have an intersection at 2, negative 1, and I have an intersection at 0, negative 3. So it makes sense that this line is crossing the circle at 2 points. Now, depending on how the circle and the line are, I could also just have no intersection or one intersection if it touches it exactly once. All right, let's go into solving using elimination. So you might see this as the addition method, know that it means that we are eliminating as well. So remember, with elimination, you want to make sure that you have the same term but with opposite signs, so that when you add them, essentially they're going to cancel out. So to do this, I'm looking at these two equations, and I see that I could potentially cancel out the y terms, but I need to first multiply the bottom one by -1. So the first one's going to stay the same. I have 4x squared plus y squared equals 13, and the bottom one, I have negative x squared now minus y squared equals -10. So again, I'm doing that so that these will cancel. Look at that, they're gone. And now I can combine my x terms together. So 4x squared minus 1x squared is 3x squared. And 13 minus 10 gives me 3. I can divide both sides by 3 and get x squared equals 1. Well, when I take the square root of x squared, I get x. And the square root of 1 is positive and -1. Okay, so don't forget, when you are taking the square root of a perfect square, you are going to have a positive and a negative branch of those numbers, because -1 times -1 is also just 1, just like the positive part of it. So now what we want to do is we want to check for that y value, right? We're looking for where these are going to intersect. So let's see what happens when x equals +1, and I go ahead and put that, let's see. It doesn't matter which one you choose. I'm just going to go with this one so that I don't have to deal with coefficients as much. So I'm going to go 1 squared plus y squared, which is what I'm solving for, equals 10. 1 squared is 1 plus y squared equals 10. Subtract the 1 over, and that gives me y squared equals 9. And I take the square root, so I get y equals plus or minus 3 again. Okay, so this already gives me two intersections. Right now I'm dealing with x equals 1. But it's telling me that I'm going to have a +3, and also at +1, I'm going to have a -3 value. So that's already two intersections, and I haven't even checked x equals -1. But we got to check it, so let's keep going. Now we're going to check what happens when x equals -1, because we said x was plus or minus 1, so we got to check the positive and the negative version of it. So I have -1 squared plus y squared. I'm using that same equation, but putting in -1 this time. When I square -1, I get 1 plus y squared equals 10. Subtract the 1, and I end up in the same place where y squared equals 9. Take the square root, and that gives me y is plus or minus 3. So again, what this is telling me is that when x equals -1, I'm having two intersections, a +3 and also a -1, a -3. So we have 4 intersections. How is that even possible? Well, let's take a look at how these graphs look. When I go to Desmos and I put these in, it makes sense because one is a circle, so you can see the circle in red, and the other one is kind of like a stretched out circle. It's an ellipse, okay? So this is how they get to intersect both of them. It's more of an oval shape. So this is what the graph looks like, and you are going to have some of these problems. So make sure you are taking the positive and negative value of both your x and your y, because that's what the graph will look like. So they are intersecting at 4 different places. Okay. Going on to the next example. Again, we are still using elimination in this case. So I'm going to rearrange this one. And the way I'm going to rearrange it is I'm going to subtract the x squared over and put it in the front. So when I subtract the x squared over, and then I still have the plus y equals 3, that's how I'm rearranging it. The reason why I want to do this is because I'm doing elimination, I want these to cancel. So in this case, I have y squared plus y. Please do not make the mistake of combining those two. They are different terms. One's y squared, one's just y. And that is going to equal 9 plus 3, which is 12. This is looking more like a quadratic, so I can subtract it over. y squared plus y minus 12 equals 0. And then I can factor from there. So I have y plus 4, y minus 3 as my factors. Set each factor equal to 0. Y plus 4 equals 0. Y minus 3 equals 0. And I get y equals negative 4. Y equals positive 3. Okay, so we got to check both of these. And we are checking to see what the x value is. We're kind of going backwards this time. So when y equals negative 4, okay, I'm going to go ahead and just substitute that to the first equation. So when y equals negative 4, I have negative 4 equals x squared plus 3. Subtract the 3 over, and I get negative 7 equals x squared. Well, what happens when I take the square root of a negative? I'm going to get an imaginary number. Oh, that's not 7i. It's going to be an imaginary number, so square root of 7i. This means for us that we're just looking for real solutions right now. So there's no real solution, okay? If you end up at the point where you have an imaginary, so a negative inside the radical, you're not going to have a real solution. So y equals negative 4 is not going to work, okay? We're not going to use that one. But I still have another one. I have y equals 3. So when y equals 3, what happens there? So I have 3 equals x squared plus 3. Subtract 3, and I end up with 0 equals x squared. And if I take the square root of that, I just get 0. So it looks like I only have one intersection this time because I only have one x value and one y value, which means I only have one solution. The graphs cross each other only once. Let's go ahead and check what the graphs look like here. I have a circle, and then I have a parabola, and then they just intersect at that one point. Okay, that's all that's happening here. So it's okay if you only have one solution. You may have more than one solution, up to 4, as we saw in the previous example. But always go back and check. If there's an imaginary solution there, then it's not going to be on our graph, so we will not be using it. Okay? All right, the last bit of the notes will be writing a system of equations and then finding the numbers that we're looking for. So kind of like a word problem, and you figuring out which values make it work. Okay, so first we have the sum of two numbers is 20. So we're just going to call the numbers x and y. So x plus y need to equal 20. And then their product means multiplication, is 96. So if I were to multiply x times y, whatever those are, we're going to get 96. Okay, so your goal here is to figure out what x is, what y is. We're going to use substitution here. So whatever method you like, I think substitution is going to be the easiest in this case. And I'm just going to solve for x. So if I solve for x, I would subtract the y over and end up with this, right? And I'm going to use that to substitute into my second equation, which is, instead of x, I'm going to say negative y plus 20. And then I'm multiplying it by y, and that's equal to 96. So negative y times y is negative y squared, and then 20 times y is plus 20y equals 96. So I want to move everything to one side because this looks like a quadratic, so this is how you solve quadratics. You set them equal to 0. So quadratic, set equal to 0. And so I'm just going to move everything to the right. That way my y squared is positive. Again, that's just a personal preference. Y squared minus 20y, and then the 96 is positive, so I keep it as positive. So think about two numbers that multiply to 96 but add up to negative 20. So you might need to do a little bit of thinking here, use your calculator, whatever you need to do. Hopefully your numbers come out to be negative 8 and negative 12. If you need to see that, I'm going to split up the middle term, which gives me y squared minus 8y minus 12y plus 96. And we can factor by grouping. So group the first two, the last two. Take out a y from the first term. Take out a negative 12 from the second term. and I end up with y minus 12, y minus 8. Okay, set those factors equal to 0, and you end up with y equals positive 12 and y equals positive 8. So your numbers, once you're done, your y values should be 8 and 12. Okay, so we just have to figure out what those corresponding x values will be. In this case, to find my x value for when y equals 8, let's just go there. So when y equals 8, I'm going to substitute it. It doesn't really matter which one you choose. I'm going to go with the x plus y equals 20. Okay, so this is the one I'm using for this. So x plus y is 8 equals 20. Therefore, x equals 12. So when y equals 8, x equals 12. So the 12 goes here. Now, when y equals 12, I have x plus 12 equals 20, x equals 8. So when y equals 12, x equals 8. And that is your final answer. So you have both sets of numbers, your x and your y. Okay, now we are going to, and I actually didn't mean to put the and there. I meant to put or, because if you're thinking about it, they're the same numbers, just switch, right? So it could either be 8, 12 or 12, 8. You just list them is fine. We just want to know that you can check for both the x and the y. So it says, find the length and width of a rectangle whose perimeter is 34 feet and whose area is 52 square feet. So thinking about how you find the perimeter of a rectangle, perimeter is going to be twice the length plus twice the width, and this is going to equal 34. Okay. My second equation is going to be about the area, and the area of a rectangle is length times width, and that's going to equal 52. All right, there's a few ways to go about this. I'm going to show it the way that I think is easiest, but again, totally up to you. We want to probably use substitution again. So I'm going to rearrange the top one, and the other method, I'll get you started on it and show you how to finish it up. We're going to get the same answer. So solve for either L or W, whichever one you like best. If I'm solving for L, I would subtract the W over. So I would have 2L equals negative 2W plus 34. And then finishing off to solve for L, I would divide both sides by 2. So the length could also be expressed as negative width plus 34. Oh, sorry, I forgot to divide the 34 by 2, 17. Okay, so then we can take this, what L is, and substitute it into that so that I can start solving for one variable. So instead of L, I can say negative W plus 17 times, and then W equals 52. Distribute that, I get negative W squared plus 17 with, and then equals 52. So again, this is starting to look like a quadratic, and we know that to solve a quadratic, I need to factor. But first, I'm going to move this 52 over. Or you can move it the other way. Actually, I told you I prefer positive x squared values. So I'm actually going to add the w squared, and I'm going to subtract the 17w that way, so that my squared value is positive. W squared minus 17 with plus 52 equals 0, and then I can factor from here. So what two numbers multiply to 52 but add up to a negative 17? Hopefully you're thinking negative 4 and negative 13. So I really factor this out to w minus 4, w minus 13. Set these equal to 0, and I get widths of 4 and 13. So we're saying that there's a potential width of 4 and 13. I could go back and substitute to figure out what my length would be. Okay, this is going to be a quick check because if you think about it, they're going to be the opposite number. but we can still check. So if W equals 4, and I'm substituting into this one, I would say that L is -4 plus 17, so my length would be 13. So I could have a width of 4 and length of 13. That's one option. Or if I have a width of 13, think of it, we're going to get a length of 4. So it's the complete opposite. You can have a rectangle essentially that is 4 by 13, or a rectangle that's 13 by 4. Okay, so these are your answers, just showing both options that the length and the width could just switch. The other option to solve this one, you could also use substitution by solving for L or W and rearranging the second equation instead. So if you chose to go that route, you have L times W equals 52. And if you wanted to solve for L, let's say, you would divide out the W. So L is 52 over W, which just means that you would take this and substitute it into this equation instead and kind of go through and do the same thing. So that one, totally up to you. I personally don't like that one because it includes a fraction, but if it works for you, we're going to get the same answer. So go for it. And that is the end of the notes. If you're interested in seeing that method where you divide by W and then substitute, that is included in the teacher notes, so definitely check that out. Thanks for watching.